This video is about the difference between empirical and molecular formulas. First thing I'd like to point out is that I'm going to go over the definitions from the very beginning. You can always skip ahead for examples. Right? The main difference between empirical formulas and molecular formulas is that empirical formulas are simple formulas and molecular formulas are real formulas. Now, an empirical formula is always a simplest whole number ratio, and a molecular formula doesn't have to be. It could be, but it doesn't have to be. So CH is the empirical formula for these two molecular formulas. These are both molecular formulas. All right. To give you another example, though, NaCl is the empirical formula and a molecular formula. It's the formula of one piece, and it's the simplest ratio. CH, there can't be any molecules that actually have CH, so CH is just an empirical formula. So if you see a formula, something like CH3, well, that's the simplest ratio. It's 1 to 3. It's an empirical formula. It might be the molecular formula. If you see a formula like C2H6, it can't be an empirical formula because it's not the simplest ratio. The simplest ratio here is CH3. All right, these are the steps for finding the empirical formula. Oh my God, don't freak out. You do need to know what these steps are. You could just refer to the overview here at the top. You assume 100 grams, convert to moles, simplify a ratio, or you need to memorize the steps. Practice makes perfect, so let's go to some practicing. Again, don't freak out. All right, here's the first practicing. I've summarized the steps down here below. All right, the first thing we're going to do is just get rid of the percentage and put grams. We can do this. It's okay to do this. We're just assuming that there's 100 grams of the compound. We don't know how many grams there actually are. If we assume 100, hey, that's fine. We're just looking for the formula. We're not looking for how much of the formula there is. All right, now we're going to start doing some math. So we're going to take the 25.9 grams of nitrogen and do step 2. Oh, sorry, it's not over n, it's over 1. The molar mass of nitrogen is 14. It's not 28. N2 is the molar mass for nitrogen gas. This isn't nitrogen gas. It's nitrogen in a compound, so it's not N2. All right, when we do that math out, we get 1.85 moles. All right, we're going to do the same thing with oxygen. We're going to do 74.1 grams of oxygen. We're going to divide by the molar mass, which is 16 grams under 1 mole. And that'll get us 4.63 moles. All right, so we did step 1, we did step 2. Let's do step 3, divide by the least moles. I want to point out, we actually have the formula now. The right ratio of the atoms is this. The problem is that that's not the lowest whole number ratio. So how do you get the lowest whole number ratio? You do this. You divide by the least number of moles. The only reason we're doing this is so that we can get the lowest whole number ratio. And because if you divide by the least, at least one of the numbers will be 1. That's 1. If you divide this, you get 2.5. All right, now we have a new updated formula. It's NO 2.5. All right, that looks really close to the end. Do not round the 2.5 to 3. It's not NO3. The deal is that this is the ratio 1 to 2.5. Right, here's where step 4 comes in. If you don't have whole numbers right now, don't round. Only round if it's really close to the whole number, kissing the whole number. Like you could round 2.05 down to 2. Or you could round 1.98 up to 2. But don't round 2.5, not good. If you don't have whole numbers, multiply by 2, 3, 4, whatever you need to do to get the lowest whole number ratio. Well, if you multiply both of these by 2, so multiply these by 2, both of them, so you keep the same ratio, you get 2 and you get 5. And that's the formula. The formula is N2O5. That's the lowest whole number ratio. It's 2 to 5. Last example, this one's a little different from the others because we're already given grams. Since we're already given grams, we don't even have to worry about step 1. We already got grams. Easy. All right, next thing is this is a little different from the other formulas because this is a chemical reaction. This is the chemical reaction of copper making copper oxide. All right. So here's the deal. What does it react to make copper oxide? I think oxygen. So if the copper oxide is 3.13 grams and the copper is 2.5 grams, well, we know the mass of copper, we know the mass of this element. What's the mass of oxygen? Well, it's whatever adds up to 3.13. So if you do the math, you get 0.63 grams has to be the mass of the oxygen. All right, if you wanted to, you could take these two numbers and figure out their percentages. That's actually not necessary. You could do that. That would be an interesting problem to do. But instead, you can actually pick up and just use those grams as is. You can start the math for copper with 2.5 grams of copper over 1. You can start the math of oxygen with 0.63 grams over 1. So step 2, by the way, we're already in grams, no need to convert to grams. Step 2, we're going to want to do molar masses. So you really should use 63.5 for copper, but I'm going to use 64. It's not going to make a big difference. And for oxygen, it's 16 grams. When we do that out, we're going to get 0.0390 moles. And guess what? 0.0393. 0393 moles. Guess what? The formula of this thing is Cu 0.093. I keep messing up the numbers. Cu 0.0390. O 0.0393. Guess what? It's just CuO. You take both those numbers, you divide by 0.039, 0.039, you get 1 and 1. So the formula is just CuO. That's it. Hope you got something out of watching this video.